so we're presenting, we're recording, and now we're going to get the PowerPoint up with some notes. Slideshow, current slide. We're going to change our screen to duplicate. We're going to do that. Slideshow, current slide. There we go. All right, so goal 1, determine if solids are similar. If it's a polyhedron, determine if all dimensions have the same scale factor. If it's a cylinder or cones, both of which then involve circles, determine if radii and either heights or slant heights have the same scale factor. Okay. Okay. Everybody's got that? All right. So now we're looking at some examples. All right. So number 3, the cone. It's got a circular surface. So all you have to check is the radius and either the height or the slant height. They're giving us the radii. What's the radius of the smaller one? 4. What's the radius of the bigger one? 8. Equals. Now I move on to the heights. What's the height of the smaller one? 9. And then what's the height of the bigger one? 18. And you can either cross multiply or simplify either way. Is that true? Is that a proportion? Yes, it is. So therefore they are similar. All right, now it asks for you to give the scale factor. And to give a particular order in which you can give the scale factor. No, so you could either give 1/2 or 2/1. Either one would be okay since they're not giving you a specific order in which to do it. Good? And then that would be the work you would have to show. Showing your proportions. Now in number 4, it is a polyhedron. So you got to check all the surfaces. For the one on the left, what are the 3 dimensions they give you? 6, 3, and 2. You can put them in any order you want. All right, but just make sure you match up the corresponding. So 6 matches up with what? 10. 3 matches up with 5. 2 matches up with 4. All right. You don't physically have to show it if you can look. In other words, what is 2/4 going to reduce down to? 1/2. Are either of the other 2 going to reduce down to 1/2? Nope. The answer is no. All right, so I don't need to physically see it. I just need to see the ratio set up. Good? Okay. All right, now moving on for 2 similar solids. So once they tell you it's similar, if the scale factor of the side lengths is A/B, the scale factor between their surface areas will be A²/B². So even though it's 3 dimensions, we're talking about areas, so it would be A²/B². All right, good. And then volume, of course, what do you think it's going to be since we're dealing with 3 dimensions? A cubed over B cubed. Okay, good. All right, so to finish up the notes, use the ratios to set up proportions and find measurements. We'll go over that in a second. Particular procedure is given the volumes, find the scale factor between their surface areas. All right, find the cube root of the volume scale factor, see sphere notes. So that's either using the math and finding the cube root or using the fraction 1/3, square the result from step 1. Good. All right. Given the surface areas, find the scale factor between their volumes. Instead of the cube root, you're going to find the square root of the surface area scale factor, and then cube the result from step 1. All right. Once you have that, if you would like to follow along by physically practicing with the calculator, go ahead and grab one. If you just want to follow along, feel free to do so. You do not have to grab one. It depends upon your learning style and what you want to do. All right. All right. Plan on your quiz for 11/4 through 11/7 to be next Wednesday. And I will be after school on Monday in the library and Tuesday in this classroom, unless I fall ill. All right. So everybody's got the notes jotted down. Everybody's good to go? All right. Let's do some practice. Escape. Image mate. Boom shakalaka. Okay. Now, these first 6 are similar to the one we just did together. I just want to go through a couple things. Number 1, all right, is number 3 a cube? Is number 3 a cube? Yes. Is number 3 the second one a cube? No. So could they possibly be similar? No. All right. So if you would rather explain it than you show the math, completely fine. You would say one's a cube and one's not a cube. All right, so you don't, if you want to do it that way, that's fine. Make sense? All right, number 4, always. All right, always. Spheres are always going to be similar. Just like circles are always similar, spheres are always similar no matter what. Because the only thing that matters is it's what? It's radius. And it's cubed, so you're going to have the same scale factor no matter what. Make sense? Because everything else is 4/3 pi. All right, number 5 is the opposite of number 3. Always. Why? Because they're both what? Cubes. All right, and you can say both cubes. All right, either tomorrow or Monday we'll start talking about regular polygons and polyhedrons, and we'll go from that. And then 6 is never. I don't even need to look at the numbers. I look at the first statement. What is 6 saying? A cylinder and a cone. What's the problem? They're not the same what? Shape. Different shapes. All right. So you have that at your disposal if you'd like to. I'll certainly understand that. All right. Everybody good? Okay. So let's go to work. All right. So we're going to start with number 8. All right. Because each pair of figures is similar. Use the given information to find the scale factor, all right, of the smaller figure to the larger figure. Okay. Number 1. Now order matters, right? Remember, this is going to be larger over smaller when I write my scale factor. all right, or larger colon smaller, depending upon your choice on how you write scale factor. Because they're saying from the smaller to the larger. So now order matters. Everybody understand? I'm not just saying scale factor. Okay. So if I look at number 8, they're telling me they're similar. This is what we're going to do. We're going to take the volume, since we're doing larger over smaller, and we're going to write them 686 pi over 128 pi. All right, everybody good with that? What are the pi's going to do to each other? Cancel out. Now, this is where the calculator steps in. For those of you that haven't done it before, we're reducing the fraction. So you have to be able to reduce fractions. With the TI-84, all right, you do 686 divided by 128. Good? You then hit the math button. Everybody sees where the math button is underneath alpha. All right? So we hit the math button. And next to number 1, what do you see? Frac 1. That will take that fraction and reduce it. So 343 over 64. So we enter it as a division problem. And if you want to, you can certainly do it at a division first. So you can turn the decimal into the fraction as well. All right, if you're more comfortable with that. Good? All good? Okay. So that gives me 343 over 64. That is important, ladies and gentlemen, because those are both what we call perfect cubes. All right? There's a number that times itself 3 times gives us that. You can either do it in your head or you can do it with the calculator. If you're going to do it with the calculator, all right, you can either do math, and then number 4. That's the cube root, remember, from the other day. And we enter it in as a division problem, 343 divided by 64. All right, good? Enter. It gives us 1.75, which is a decimal. Math, 1, boom. What does it give us? A fraction, 7 over 4. All right. And my final answer is 7 over 4. Or 7:4, depending upon your preference. If you need to, if that's going to be uncomfortable for you, you got to write down the steps in your notes, because I'm not telling you how to do it when we come in on Wednesday. That's something you're responsible for knowing, how to use the calculator. That's the actual scale factor. Is what the problem asks for. All right, I understand what you're saying. So basically, let's go back to that, because that's a good point. What they're asking us is to find the scale factor. That's linear. So the 7 to 4 is the linear scale factor between the sides. So in other words, if we look at the diagram, their radii and heights are in a 7 to 4 ratio for the linear scale factor. So if they just say scale factor, that's what we're going to do. That's the linear. If they ask for the scale factor between their areas or volumes, that's another step. Make sense? If they give you the expression 2, so when they say the scale factor, I'm going to abbreviate a little bit, of A to B. What they're asking you is, what do we multiply by, take the dimensions of A, and turn them into B. So that's why the B comes on top and the A goes on the bottom. So whatever comes after the 2 goes on top, whatever comes before the 2 goes on the bottom. Sure. That's when you're finding surface area. Look at the top of your notes. The notes say when you're finding the surface area. Got me? So it's important. The statement she makes, you got to make sure, you know what I mean, what you're doing, what they ask for. Make sense? So like if they were then to find the scale factor between their surface area, yes, you'd square it. Or if they wanted to find the scale factor between their volumes, which we'll do, we'll cube it. But this problem just asks for the scale factor. Good? All right, and we got 2 days to do this, so I'm good to go. I got no problem going over anything because this is tricky. It's not hard, it's just tricky. Because you got to keep everything straight. The math's not bad, and a lot of it can be done with this, but you just got to keep everything straight. All right, so I go to 9. All right, I go to 9. Instead of volumes, what are they giving me? Surface areas. First part's the same. I take 150, and I put it over what? 54. Now, there's no rule that says you have to use the calculator. You see it. So, in other words, are 150 and 54 both perfect, both even numbers? Yeah, so if you want to continue doing it in your head, feel free to. All right, that would give me 75 over 27. 3 goes into both. Eventually, I would get 25 over 9. All right, eventually, I would get 25 over 9. Either using the calculator or your brain, whatever you want to do. Now we're dealing with areas. Why are 25 and 9 good numbers? Because they're both perfect squares. That's the scale factor between their surface areas. So to get their regular scale factor, instead of doing the cube root, now we're just going to do the what? Square root. Now you can put in the calculator and do square root if you want, or square root of a fraction, hopefully you learned last year, is the square root of both parts. So what's the square root of 25? 5. Square root of 9? 3. So 5 over 3 is the scale factor, So again, I can't reinforce more because Nora asked about it. It was a good question. When they ask for just scale factor, you're looking for the linear scale factor. All right? Everybody good with that idea and distinguishing between the two? All right. 2 similar cones have heights 4 and 12 meters. Now, we go back to A. And this goes back to what you guys were asking about. Are they asking for a particular order in this one? No. So you can write either what? 12 over 4 or 4 over what? 12. Either way, it doesn't reduce. Yes. This would be 3 over 1. This would be 1 over 3. Now, this is important. So you can pick any order you want. You just have to stay consistent. You can't flip back and forth. So you can't choose the 12 over 4 for this one, and then for B, go to the 4 over 12. You just have to stay consistent. I don't care which one you do. So if you stay consistent to find the ratio of their surface areas, now I take the 3 over 1 and I square. What's 3 squared? 9. So between it would be either 9 over 1 or 1 over 9. But again, you've got to be consistent. So Nora, does this help explain what you asked about? Yeah. Okay. And then the ratio of their volumes, instead of squaring it, you would cube it. All right, 3 cubed is 27. 1 cubed is still going to be 1. 1's going to be 1. Good? Everybody good? All right, now one of my favorite things of the year, a word problem, because it makes you think. It says a shipping box holds 450 golf balls. A larger shipping box has dimensions triple the size of the other box. How many golf balls does the larger box hold? Now, there's no measurements given here, so it's all up in your head. You got to think it out. That's why it's a great question. When you're thinking of golf balls and fitting them in a shipping box, is it area or volume? Volume. Everybody understand that? It's volume. Make sense? So this is similar volume. So what we're going to do is we're going to take the word triple. And what does that mean? Well, triple just means a scale factor of what? 3 to 1. Does everybody see that? If I double it, it would be 2 to 1. If it's 10 times the size, it would be 10 to 1. Make sense? All right. Now, because it's volume, what are we going to do with that scale factor? Cube it. 3 cubed from the upper problem, 27. 1 cubed is still 1. Well, what does that mean in the real world? That means I can fit how many more times golf balls in there? 27. That makes sense. Okay, so I'm just going to take 450 and multiply by what? 27. and I get 12,150. Can you visualize why it's that many? Or is anybody struggling with that? Because I can give it to you visually of why that's the case. Okay, so let's just assume it's a rectangular prism. All right, so I'm going to draw that out. All right, so I'm going to triple the dimensions. So I'm going to go this way. I'm going to go this way. That makes sense. Tripling the dimensions. I'm making it 3 times as long and 3 times as wide. Make sense? Good? So that means all these are this. So then I would have 9 times as many, right? Well, here's the thing. You're also tripling the what? The depth, the height. So not only do I have to go 3 across and 3 up and down, I got to go 3 back. And if you count all the boxes, you got 9, 18, 27. That's why that works actually in a way. All right? Good? But for those of you that aren't worried about that, you just realize you're using the scale factor with volume and you're working from it. Okay? All right, let's flip to the back. Let's see what else we got. All right. The area and volume of 2 similar figures are given. The volume of the larger figure is given. Find the volume of the smaller figure. Okay. So they give us the surface area, which is 94 over 846. All right. Is that good? All right. What's our first move? Reduce it, right? So I take 94 divided by 846, math 1. And it reduces down to 1 over 9. All right? Again, that's when the calculator comes in hand because that's not going to be something you commonly see. So that's 1 over 9. All right? Now you got 2 routes you can go with. To get the regular scale factor, we would do the square root of both, right? Okay? So that would be the square root of 1, which is 1, and the square root of 9, which is what? 3. Make sense? But we're dealing with volume, and volume deals with raising it to what power? So you take the scale factor, and you what? You cube it. And that would give me 1 over 27. All right? That represents the scale factor between their volumes. Everybody good with that idea? Okay. Now, we then set that equal to, they're giving us the volume of the larger figure, which is 1620. All right? Am I going to put that across from the 1 or across from the 27? Across from the 27 to give me 1620 over x. And now I'm going to solve it using a proportion. What's 1 times 1620? 1620. What am I then going to divide that by? Divided by 27. And I believe we get a volume of 60 meters cubed. All right. Now, if you feel you're pretty proficient with a calculator and roots, here's the idea. A square root is the same thing as 1/2. Got me? And then, so basically, when I raise it to a square root, I'm raising it to a 1/2, and then I'm cubing it. From last year with laws of exponents, when you raise an exponent to another exponent, what do? You multiply. And that would be x to the 3/2. That combines those steps at the same time. All right? So what you can do is you can take 9 and raise it to the 3/2. And you get the 27 right away. I wouldn't do it, but I'm just telling you, for those of you that want to skip that step, I wouldn't do it. You're going to have plenty of time to do it this way. This is most likely in your wheelhouse in terms of stuff you've been displayed to. That's next year, but again, if you feel you're proficient, you can go to work on that. So if you would, please work on number 13. God bless. Everybody good with the scale factor being 2/5? Everybody good with the scale factor of their volumes and being 8/125? Everybody then good setting that equal to the proportion x over 1562.5. If you flip the 8/125, you just got to flip the x in the 1562.5, and then you get 100. All right? Good? All right, let's tackle 15 and 16 then. Number 15. The volumes of two similar figures are given. The surface area of the larger figure is given. Find the surface area of the smaller figure. Okay. So now instead of surface areas, they're giving us volumes. So we start with the given volumes, which is 384 over 10,368. Volumes get pretty big really quick. So would it make sense to reduce that right away? All right, so I take 384, divide that by 10,368, math 1, and it gives me 1/27. All right, so that's the scale factor between their volumes, 1/27. The difference is they're giving us the volumes. So if we want the scale factor, remember volume is cubed. So instead of finding the square root, what would it make sense to do? Cube root. And the cube root of 1/27 is 1/3. Make sense? But we want to work with area, which is squared. So we're going to take that and then what? Squared. 1/3 squared gives me what? 1/9. They give me the surface area of the larger figure, which is 3168. Do I put that with the 1 or the 9? 9. And then I just what? Cross multiply 3168 divided by 9. And you get x equals 352. All right. So if you would, please work on number 16. Everybody good with the 1/8 for the scale factor between the volumes? Everybody good with 1/2 with their scale factor? Everybody good with 1/4, the scale factor between their areas? If the scale factor is 1/4, can I simply find 1/4 of 864 in order to find the new surface area? Absolutely, and I get 216 inches squared. Good. All right, let's do one word problem, and then we'll do the rest tomorrow. 17, a cylindrical thermos has a radius of 3 inches and is 12 inches high. It holds 20 fluid ounces. To the nearest ounce, how many ounces will a similar thermos with a radius of 4 inches hold? Okay, so fluid ounces. Area or volume? Volume. Make sense? Okay, so cylindrical thermos has a radius of 3 and 12 inches high. So I find its volume. Pi 3 squared times 12. Make sense? All right, 3 squared. 9 times 12 is 108. Volume is 108 pi. I would strongly suggest when working with similar figures, you leave it in terms of pi. It's going to make your life so much easier. All right, now, so if I look at their scale factor, first one had a radius of 3, second one has a radius of 4. So the scale factor would be what? 4/3. Everybody get with that? And it doesn't matter which dimension they give you as long as you use coordinating dimensions. But it's volume, so what do we have to raise both of those to? What power? Third, right? So 4 cubed is 64. 3 cubed is 27. The 108 pi, is that my smaller thermos or my bigger thermos? Smaller thermos. All right. Now, I'm going to take either 108 and multiply by what? 64, and then divide that by what? 27, and add what at the end? Pi. All right. Make sense? Okay. So 64 times 108 divided by 27. I get 256. It's 256 pi. All right, that gives me the volume of the figure. Does that help me at all? No, because what did it ask for? Simply asked for the what? The ounces. This is what similarity allows us to do. Similarity allows us to not go through all that and say, okay, the smaller one holds how many ounces? 20. We're trying to figure out the bigger one, which would be X. Smaller one was the 27. Bigger one was the 64. And we'll finish that up tomorrow. If you need either the 11.6 that's due tonight or the 11.7 that's going to be due on Sunday, they're both up there. Have a good day, guys. Be safe. See you tomorrow. Bye, guys. You good? You too. Why don't we just move the whole part next? Get this stuff off. Unplug it, got it? Yes. And then it's all yours.
Thank you.
You're welcome. Thanks for taking that over there.